The operations presented in this video are meant to be instructional to ensure quality construction. This video is not intended to provide a comprehensive overview of safety procedures. It is the responsibility of the viewer of this video to follow all safety procedures, rules, and standards established by private companies, government agencies, and contractors. Slab stabilization, also called undersealing, subsealing, or pavement grouting, is non-destructive and needed when the voids occur in the underlying foundation, leaving the concrete pavement lacking a stable support system. These voids can lead to poor joint performance, slab deflection, or rocking, all signs that the pavement has become unsupported under the current traffic loads and will restore slab support. This video will provide a brief overview of the inspection process for slab stabilization operations. While there are many variables involved, including construction techniques and material selection, this video will focus specifically on the inspection process in the field after the deflection testing or visual verification has been completed to determine what slabs require stabilization on site. We will use high-density polyurethane for the stabilizing material. Before slab stabilization begins, and at a minimum, the inspector must be familiar with the following key references and components of the operation. RC standards, specifically RC 26M concrete pavement rehabilitation, slab stabilization deflection testing, Pub 408 specifications, section 679, related contract special provisions, if applicable, contractor's field quality control plan, project documentation procedures, known as ECMS PSA entries, stabilization materials being used, that is, cement grout, asphalt grout, or high-density polyurethane grout, equipment requirements, sequence of operations. Concrete Preservation Guide, Chapter 4, Slab Stabilization. Understanding these elements ensures inspections are thorough, consistent, and aligned with PennDOT requirements. Prior to starting slab stabilization work, the contractor must submit documentation demonstrating that qualified, experienced personnel, such as the crew supervisor and injection nozzle operators, will be assigned to the operation. In addition, a detailed field quality control plan must be submitted to the department for review and approval. This plan should clearly outline all procedures specific to slab stabilization work, including the following: proposed hole spacing, depth, diameter, drilling methods, and the planned injection sequence. Methods to locate pavement reinforcement prior to drilling, if applicable. A list of equipment to be used, including supply pumps, valves, mixing tools, injection guns, and related components. Procedures for establishing and maintaining line and grade of the stabilized slabs. Curing time requirements and timelines for reopening the pavement to traffic. As with all construction field operations, safety is a top priority. Before beginning slab stabilization work, observe all normal safety rules in the operation of pressure pumps and other related on-site equipment. Ensure that all safety protocols are in place, including the following: establishing the proper maintenance and protection of traffic in accordance with the accepted traffic control plan, verifying that all personnel are equipped with the required personal protective equipment, known as PPE, for their assigned tasks. The high-density polyurethane grout used for injection must be supplied by a manufacturer listed in Bulletin 15. Each shipment to the project must include an appropriate material data sheet and completed CS 4171 supplier certification form certifying that the material conforms to the following requirements as indicated in Pub 408 Section 679.2 C1. Next, the inspector must verify that all injection hole locations have been properly marked on the pavement surface before any drilling operations begin. These markings should correspond to the slabs identified earlier for stabilization during the deflection testing or visual verification, and must follow the hole patterns shown in RC26M and the contractor's approved quality control plan. Any proposed changes or adjustments to the injection hole layout must be reviewed, approved, and incorporated into the updated field QC plan prior to proceeding with the drilling operations. The contractor will commence with drilling the injection holes into the designated concrete slabs. Holes must not exceed 5/8 inch in diameter and should be drilled to a depth sufficient to reach the underlying unstable material. All holes must be drilled smoothly and perpendicular to the pavement surface without breaking out the bottom of the slab. No more holes should be drilled during a single day than can be filled that same day, unless approved by the department representative. The contractor must also provide cylindrical plugs of proper length and diameter to seal the holes. Each plug should have a tapered end to allow for driving it into the hole up to 2 inches deep. Prepare the high-density polyurethane by mixing the components in accordance with the manufacturer's specifications. Accurate mixing is critical to ensure proper expansion, bonding, and long-term performance. The injection pump unit must be capable of injecting high-density polyurethane grout at a controlled rate beneath the pavement and must also manage the rate of pavement lift during the process. The pump unit equipment must meet as a minimum the following operational requirements. Be equipped with a calibrated meter to measure the injected grout quantity at each location. Include a flow control system to prevent excessive slab lifting. Have a digital display output showing the amount of material injected in pounds. And feature a manual reset button for tracking material totals. The contractor must provide certification of calibration testing, showing the equipment was calibrated within the 12 months preceding the project start. Additionally, the pump unit must have pressure and temperature controls to maintain proper conditions for accurate material mixing and proportioning. Next, the contractor's experienced nozzle crew will begin injecting the high-density polyurethane beneath the slab into the pre-drilled holes. The amount of slab lift must be carefully controlled by regulating the injection rate with the pump unit and injection gun. Slab movement, meaning vertical movement testing, must be monitored in accordance with Publication 408, Section 679.3. The monitoring equipment must be capable of detecting slab movement as small as 1/1000th of an inch, sensing simultaneous lift at the pavement edge or any two adjacent slab corners and the adjoining shoulder. Any upward movement of the slab exceeding 5/100ths of an inch is not permitted for slab stabilization. Slab jacking under Section 681 is to be used for raising slabs to the correct elevation. After removing the injection nozzle, the contractor must remove any excess material from the pavement surface. Pumping must cease immediately upon any sign of vertical slab movement, and the final slab alignment must be confirmed to ensure proper drainage. After injection has been completed, the contractor must patch all holes using a non-shrinking sand, cement grout, or an approved quick-set patching material. At the end of each workday, all debris resulting from slab stabilization operations must be thoroughly cleaned up to the satisfaction of the department representative. Traffic may be permitted on the stabilized pavement no sooner than 30 minutes after the high-density polyurethane grout injection is complete. However, opening to traffic times must also comply with the contractor's approved field quality control plan and the manufacturer's recommendations for the specific stabilizing material that was used. Slab stabilization isn't just about injecting material beneath the pavement. It's about restoring integrity, extending service life, and protecting Pennsylvania's roadway infrastructure for years to come. As an inspector, your attention to detail at every stage of the operation, from layout to lift monitoring, plays a vital role in the success of the project. Thanks to all for your commitment to safety, quality, and public service. Special thanks to Geotech Services Incorporated, Eurotech USA Incorporated, and T. Lucky Sons Incorporated in the making of this video.